Good morning, chemistry students. Here is your last video going over corrections for page 250, question number 22. Question 22 says, tin 2 fluoride, formerly found in many kinds of toothpaste, is formed in this reaction. Letter A, how many liters of hydrogen fluoride are needed to produce 9.40 liters of hydrogen at STP? So how many liters of HF, so question mark liters, okay, are needed to produce 9.40 liters of hydrogen, and they do tell us it's STP. Okay, so again, I'm going to start with my given, and this is a volume problem, so I know I'm going to have to use multiple conversion factors. So I'm going to start with 9.40 liters of hydrogen. I'm going to use molar volume to convert liters of hydrogen to moles of hydrogen. And again, I need to change from one substance to another, so I need a mole ratio. So moles of hydrogen will go on the bottom, and moles of hydrogen fluoride are going to go on the top. Again, I'm in moles of hydrogen fluoride. I want liters, so I'm going to use molar volume again. Moles of hydrogen fluoride go on the bottom. Liters of hydrogen fluoride go on the top. And that's going to leave me in liters of hydrogen fluoride, which I want. So again, the tools I've used here, this is my molar volume. This is a mole ratio, because again, it's our only way to change from one substance to another. And this is molar volume again. So again, if you're not sure what numbers to fill in for those, you're going to look at your chemistry toolkit. Your molar volume tool has a 1 in front of moles and 22.4 liters in front of, or 22.4 in front of liters. Mole ratio, our numbers come from our coefficients of our balanced equation. So our coefficient of hydrogen fluoride is a 2, and our coefficient of hydrogen is a 1. For, again, molar volume, I look at it, and in front of liters is 22.4, and in front of moles is 1. Now, this is one where I should be kind of smart about putting it in my calculator, because not only are my units canceling out, but notice I have 22.4 liters in both my numerator and my denominator. Okay, so effectively in my calculator, I'm going to be able to put this in as 9.4 times 2. I should have 3 significant figures because, again, this number has 3 significant figures. So my answer with 3 significant figures is going to be 18.8. I do need to make sure I have units on it. Okay, so it's liters of hydrogen fluoride. Letter B says how many molecules of hydrogen are produced by the reaction of tin with 20.0 liters hydrogen fluoride at STP. So again, they have stipulated STP for us, okay, and we want to know how many molecules of hydrogen are produced by the reaction of tin with 20 liters of hydrogen fluoride at STP. So again, this would be a particle volume problem. Again, I see I'm going to change from one substance to another, which means I'm going to have to use a mole ratio. So I'm going to start with my given, which is the 20 liters of hydrogen fluoride. Molar volume is what I'm going to use to convert liters of hydrogen fluoride to moles of hydrogen fluoride. Moles of hydrogen fluoride will have to go in the denominator. And I'm going to put moles of hydrogen in my numerator because that's the substance I'm changing to. But again, I don't want moles, I want molecules. Now, to use moles and molecules, that tool on my toolkit, it has to be a molecular compound, which, okay, hydrogen is. So I'm going to put moles of hydrogen on the bottom and molecules of hydrogen on the top. And again, I'm going to be in the correct units. So the tools that I've used here, again, this is my tool of molar volume. This is my mole ratio because it's my only way to change from one substance to another. And then this is one of my count conversion factors. So looking at my tools on my toolkit, if you're not sure, and for molar volume, in front of moles is 1, in front of liters is 22.4. For my mole ratio, those are my coefficients for my balanced equation. My coefficient on hydrogen is 1, and my coefficient on hydrogen fluoride is 2. My count one, again, the number that goes in front of moles is 1, and the number that goes in front of molecules is Avogadro's number. Okay, so again, this is one that you need to be a little bit conscientious about how you put it in your calculator. My suggestion would be you're going to use some parentheses. So you want to do 20 times 6.022, that E button 23, divided by, and again I need to use parentheses because I have two things I want to divide by that are multiplied together. So if you put that in your calculator that way, you should get the correct answer. Again, I should have 3 significant figures because the number I'm given has 3 significant figures. So you should end up with 2.69 times 10, okay, to the 23rd molecules of hydrogen. 22C. How many grams of tin 2 fluoride can be made by reacting 7.42 times 10 to the 24th molecules of hydrogen fluoride with tin? So how many grams of SnF2 can be made by reacting 7.42 times 10 to the 24th molecules of hydrogen fluoride? So this is a particle mass problem. Again, I'm changing from one substance to another, so I know I'm going to have to use a mole ratio. So I'm going to have to convert molecules to moles, and I'll have to convert moles to grams. So again, I still start with my given, which is my 7.42 times 10 to the 24th molecules of hydrogen fluoride. Okay. Molecules of hydrogen fluoride have to go in the denominator. I'm going to go to moles of hydrogen fluoride in the numerator. I'm going to have moles of hydrogen fluoride in the denominator and moles of the tin fluoride in the numerator. Okay. And then I'm going to have my moles of tin fluoride in my denominator. And I'm going to have grams of my tin fluoride in my numerator, and that'll be my last conversion factor. So I'll put my equals down here because I sort of ran out of room. Okay, again, in terms of my tools, this is my count tool. This is my mole ratio that I have to use because I'm changing from one substance to another. And this is molar mass. So again, my count, 1 goes in front of moles, and Avogadro's number goes in front of molecules. My mole ratio, it's my coefficient, so I have a coefficient of 1 in front of the tin 2 fluoride and a coefficient of 2 in front of hydrogen fluoride. molar mass, and 1 goes in front of my moles. And then again, remember to get the number in front of tin fluoride, I add 1 tin and 2 fluorides together, which is 156.70, okay, 6 grams, okay. Again, when you do this on your calculator, you should get 3 significant figures again, 965 grams of tin 2 fluoride. Again, this is one that we'll kind of talk a little bit about how to put it in your calculator, right? Again, I'm going to want to use parentheses. 7.42 E24. Again, I don't need to multiply by 1 and 1, right? Everybody knows that's not doing anything. So times 156.706, okay? Divided by, again, I need parentheses, 6.022 E23 times 2. And that should give you your answer. I hope that helped if you were struggling with this. I hope you have a wonderful summer. Seniors, good luck in your next step. The rest of you, I hope at some point next fall you'll stop by and say hello. Talk to you later. Enjoy your summer.